Hello there, and welcome to Whispers of Science, where curiosity gets cozy and the mysteries of the universe unfold like a gentle bedtime story. Tonight, we're exploring one of the most fundamental forces that shapes our existence: gravity, the invisible hand that keeps your feet planted on the ground, your coffee in your cup, and our entire planet dancing around the sun. It's a force so constant, so reliable, that we barely notice it until perhaps we trip, and gravity kindly reminds us it's been there all along. But what exactly is this mysterious pull that governs everything from falling apples to spinning galaxies? And why, after centuries of study, do we still find ourselves humbled by its elegant complexity before we begin our journey into the heart of this cosmic embrace? I'd love to know where in the world you're listening from tonight. And as you settle in, perhaps you can feel gravity's gentle tug pulling you deeper into your chair or bed, reminding you that you're perfectly anchored to this spinning rock we call home. If you find this exploration soothing or intriguing, I'd be ever so grateful if you gave the video a like and subscribed. It helps this little corner of calm reach others who might need a peaceful pause in their day, and who knows, maybe someone else is wondering right now why they don't float away when they're not paying attention. Now, I do hope this isn't so fascinating that it keeps you awake, though. If it does, at least, you'll drift off knowing something beautiful about the fabric of reality. So take a deep breath, let your thoughts settle, and let's begin. Because somewhere between the falling of leaves and the rising of tides lies one of nature's most profound whispers. Gravity has been with us since the very beginning, not just of human civilization, but since the first moments after the Big Bang, when matter began to clump together in the cosmic darkness. It's the reason stars were born, the reason planets formed, and ultimately the reason you exist at all, to breathe and wonder about these very questions. Yet for something so fundamental, gravity remains beautifully mysterious. It's the weakest of the four fundamental forces in physics, millions of times weaker than the electromagnetic force that keeps atoms together, and yet it's the force that shapes the largest structures in the universe, from solar systems to galaxy clusters spanning billions of light years. Imagine, if you will, that you're holding a feather in one hand and a stone in the other. If you drop them both, which will hit the ground first? Your intuition probably says the stone, and for most of human history, that's exactly what people believed. Heavier objects fall faster. It makes perfect sense, doesn't it? But here's where gravity begins to whisper its first secret. If you could somehow remove all the air from around those objects, they would fall at exactly the same rate. The feather and the stone would hit the ground simultaneously. This revelation, first proposed by Galileo Galilei in the early 17th century, was so counterintuitive that it challenged everything people thought they knew about the natural world. Galileo didn't just theorize about this, he tested it. Legend has it that he dropped objects of different weights from the Leaning Tower of Pisa. Though historians debate whether this actually happened, the principle remains revolutionary. In a vacuum, all objects fall at the same rate, regardless of their mass. This means that gravity doesn't actually pull on mass the way we might imagine. Instead, it does something far more elegant. To understand what gravity really does, we need to step back and look at the bigger picture. Imagine you're walking across a perfectly flat field with your eyes closed. You'd walk in a straight line, wouldn't you? But now imagine that same field has gentle hills and valleys scattered across it. Still walking with your eyes closed, you'd find yourself naturally following the contours of the landscape, turning left here, curving right there, not because something is pushing or pulling you, but because you're simply following the easiest path. This is closer to how gravity actually works, according to our current understanding. It doesn't reach out and grab objects like an invisible hand. Instead, it curves the very fabric of space and time, creating hills and valleys in what physicists call spacetime, and objects simply follow the straightest possible path through this curved landscape. It's a bit like a marble rolling across a stretched rubber sheet. If the sheet is flat, the marble rolls in a straight line. But if you place a heavy bowling ball in the center of the sheet, it creates a depression, and now the marble will curve around that depression, following the contour of the warped surface. The marble isn't being pulled by the bowling ball, it's simply following the geometry of the curved sheet. This is the heart of Einstein's general theory of relativity published in 1915, and it completely revolutionized our understanding of gravity. Einstein showed us that what we experience as the force of gravity is actually the curvature of spacetime caused by mass and energy. The more massive an object, the deeper the curve it creates in spacetime, and the more other objects will be deflected as they pass nearby. But let's step back for a moment and appreciate just how strange this really is. We're saying that mass and energy literally bend the fabric of reality itself, creating invisible highways through space that objects follow, not because they're being pushed or pulled, but because curved space-time is simply the landscape they travel through. Think about Earth. For instance, our planet's mass creates a depression in space-time, like a bowling ball on that rubber sheet. The moon isn't orbiting Earth because Earth is pulling on it with some mysterious force. Instead, the moon is traveling in what it perceives to be a straight line through space. But because Earth has curved space-time around itself, the moon's straight line path becomes an orbit. This might sound abstract, but we can observe these effects directly. Light itself follows the curves of space-time when light from distant stars passes near the sun. During a solar eclipse, we can see that the starlight bends slightly, making the stars appear to be in slightly different positions than they actually are. This bending of light by gravity is called gravitational lensing, and it's become one of our most powerful tools for studying the universe. But here's where gravity gets even more mysterious. If gravity is just the curvature of spacetime, then what exactly is doing the curving, and why do some things curve spacetime more than others? The answer lies in one of the most famous equations in all of physics, Einstein's field equations, which relate the curvature of spacetime to the energy and matter it contains in simple terms. These equations tell us that energy and mass tell spacetime how to curve, and curved spacetime tells matter how to move. It's a beautiful feedback loop where matter shapes the stage and the stage directs the dance. But the deeper we look, the more questions arise. For instance, we've discovered that the universe is filled with something we call dark matter, which seems to have gravitational effects but doesn't interact with light or ordinary matter in any way. We can detect it's like having invisible dancers on our cosmic stage. We can see their gravitational footprints, the way they curve space-time, but we can't see the dancers themselves. Even more puzzling is dark energy, a mysterious force that seems to be causing the expansion of the universe to accelerate. It's as if the very fabric of space is being stretched by something we can't identify, and this dark energy makes up roughly 68% of the universe, while dark matter accounts for another 27%. That means everything we can see and touch, all the stars, planets, and galaxies, only make up about 5% of reality. So when we talk about gravity, we're really talking about our best current understanding of something far grander and more mysterious than we initially realized. We're exploring the fundamental architecture of reality itself, the invisible framework that holds everything together from the smallest asteroid to the largest galaxy cluster. But gravity isn't just about massive objects in distant space. It's intimately woven into your everyday experience right now. As you listen to this, gravity is pressing you gently into your seat. It's keeping the air molecules around you from floating away. It's maintaining the pressure in your blood vessels and helping your inner ear determine which way is up every breath you take. Every step you make is a negotiation with gravity. Your muscles have evolved to work against it. Your bones have grown dense enough to support you in its embrace. Even your heart has to pump blood uphill against gravity's pull to reach your brain. And when you sleep, gravity helps settle your body into rest, drawing you down into the comfort of your bed. And yet, despite its constant presence, gravity remains the most mysterious of all the fundamental forces. We still don't know how it works at the quantum level, the smallest scales of reality. While we have beautiful theories that describe how gravity behaves on large scales from planets to galaxies, these theories break down when we try to apply them to the quantum world. This is one of the greatest unsolved puzzles in physics, the search for a theory of quantum gravity that could unify our understanding of the very large with our understanding of the very small. Some physicists propose that gravity might be carried by hypothetical particles called gravitons. Others suggest that space and time themselves might be made of discrete building blocks, like pixels on a cosmic screen. But perhaps the most humbling aspect of gravity is how it connects us to the deepest questions about existence itself. When we study gravity, we're studying the very nature of space and time, the beginning and ultimate fate of the universe, and our place in the grand cosmic story. Every time you feel gravity's gentle pull, you're experiencing something that connects you to every other massive object in the universe. The gravitational field of your body extends infinitely in all directions, growing weaker with distance, but never quite reaching zero. This means that technically you have a gravitational influence on every star in every galaxy, though admittedly a very, very small one. In a sense, gravity makes the universe one interconnected whole where every piece of matter influences every other piece, creating an invisible web of relationships that spans cosmic distances. It's a force that speaks to the fundamental interconnectedness of all things, reminding us that we're not separate from the universe, but woven into its very fabric. As we continue our exploration, in the next part of this journey, we'll delve deeper into gravity's role in shaping the cosmos from the birth of stars to the formation of black holes, those mysterious objects where gravity becomes so strong that not even light can escape. We'll discover how gravity sculpts galaxies, guides the dance of planets, and creates some of the most spectacular phenomena in the universe. But for now, take a moment to appreciate the quiet miracle of gravity's constant companionship. It's there in the gentle weight of your blanket, the way your tea settles in your cup, and the comforting knowledge that no matter how chaotic the world might seem, there's at least one force you can always count on to keep your feet on the ground. In the grand theater of the cosmos, gravity plays both director and stagehand, orchestrating performances that span billions of years, and yet it does so with such subtle grace that we often forget we're watching the show unfold around us every moment of every day. Consider for a moment the journey of a single raindrop as it forms high in the atmosphere, water molecules drawn together by forces we barely notice until gravity whispers its invitation, and down the droplet falls not in a straight line, as you might expect, but in a complex dance influenced by air currents, temperature gradients, and the spinning of our planet beneath it. That simple drop carries within its descent the story of gravity's influence across scales from the molecular to the planetary. But gravity's artistry extends far beyond our earthly experience. Look up on a clear night, and you're witnessing gravity's grandest choreography. Every twinkling star owes its existence to gravity's patient work over millions of years, slowly gathering cosmic dust and gas into increasingly dense clouds until the pressure and temperature become so intense that nuclear fusion ignites and a star is born. This stellar birth is gravity's most spectacular magic trick. It takes the cold emptiness of space, sprinkled with the lightest elements, hydrogen and helium mostly, and through nothing but patient, persistent attraction creates furnaces so hot they forge the heavier elements that make up our world, the carbon in your body, the oxygen you breathe, the iron in your blood. All were created in the hearts of dying stars, held together and compressed by gravity's embrace. Yet gravity is also a master of destruction when a massive star exhausts its nuclear fuel. Gravity doesn't simply switch off. Instead, it stages one of the universe's most dramatic finales. The star's core collapses in a fraction of a second, creating pressures so intense that protons and electrons are crushed together, forming neutrons in the process. The star explodes outward in what we call a supernova, briefly outshining an entire galaxy of billions of stars. But here's where gravity reveals another of its secrets. Sometimes, after such an explosion, the remaining core is so massive that gravity's grip becomes inescapable even by light itself. This creates what we call a black hole, a region of spacetime so severely curved that it forms a kind of cosmic whirlpool from which nothing can return. It's gravity at its most extreme, creating boundaries in space beyond which our normal understanding of physics begins to break down. Black holes might sound like cosmic monsters, devouring everything in their path, but they're actually quite well behaved. They don't reach out and snatch distant objects. Instead, they simply sit there, curving space time so dramatically that anything venturing too close finds itself on a one way journey toward the center. It's like a cosmic drain that only affects things that wander too near. And yet, these seemingly destructive forces play crucial roles in the universe's grand design. Many galaxies, including our own Milky Way, have supermassive black holes at their centers, containing millions or even billions of times the mass of our Sun. These galactic anchors help organize the swirling dance of stars, providing gravitational stability to the entire galaxy structure. Our own solar system tells a beautiful story of gravity's organizing power 4.5 billion years ago. There was no Earth, no sun, no planets, just a vast cloud of gas and dust slowly rotating in space. But gravity began its patient work, pulling material together bit by bit. The densest region became our sun, while smaller clumps formed the planets, each finding its place in the delicate balance between gravitational attraction and orbital motion. This is why the planets orbit the sun in roughly the same plane, and why they all travel in the same direction. They're following the ancient memory of that original rotating cloud preserved and refined by billions of years of gravitational choreography. It's a dance so precisely balanced that we can predict where every planet will be thousands of years into the future. But gravity's influence on our solar system extends far beyond the major planets. It shepherds countless asteroids in the belt between Mars and Jupiter, keeps comets in their elongated orbits, bringing them back to visit the inner solar system with clockwork regularity, and maintains the delicate gravitational relationships that have kept our Earth in the habitable zone, where liquid water can exist for billions of years. Closer to home, gravity shapes our planet in ways both obvious and subtle. It's responsible for the tides, those gentle rhythms of rising and falling seas that have pulsed along our coastlines for eons. The moon's gravitational pull stretches our oceans, creating bulges of water that follow the moon's position as Earth rotates. These tidal forces also gradually slow our planet's rotation, making our days slightly longer over geological time. Gravity also drives the great cycles that make our planet dynamic and alive. It pulls water from the oceans into the atmosphere, where it forms clouds and eventually falls as rain feeding rivers that carve valleys and canyons on their way back to the sea. It draws molten rock upward through volcanic vents, recycling the planet's crust and releasing gases that help maintain our atmosphere. Even the air you breathe owes its presence to gravity. Without our planet's gravitational field, the atmosphere would gradually escape into space, leaving Earth as barren as the moon. This invisible envelope of gases, held close by gravity's embrace, creates the greenhouse effect that keeps our world warm enough for life, provides the pressure that allows liquid water to exist, and shields us from harmful radiation from space. But perhaps gravity's most profound gift to life on Earth is stability. Our planet's orbit around the sun varies only slightly over time, keeping us in that narrow band where temperatures allow liquid water to exist for billions of years. This gravitational stability has given life the time it needs to evolve from simple single celled organisms to the magnificent complexity we see today. And what complexity it is! Gravity has shaped the evolution of life in countless ways. It determined the maximum size that animals could grow on land, because bones and muscles must be strong enough to support weight against gravity's pull. It influenced the development of our inner ear, giving us the sense of balance that allows us to navigate three-dimensional space. It even affects how our bodies develop before birth, as cells respond to gravitational cues during the delicate process of embryonic growth. In the depths of our oceans, where sunlight never penetrates, gravity creates the deep currents that circulate nutrients and oxygen around the globe. These gravitational flows help maintain the delicate chemical balance that makes our planet habitable, connecting the deepest trenches to the surface waters. in a vast, slow breathing that has continued for billions of years. Gravity also reveals itself in the most unexpected places. The timing of your heartbeat is influenced by gravity's effect on blood flow. The way your bones grow and maintain their strength is a constant negotiation with gravitational stress. Even your sleep cycles are subtly influenced by tidal forces that affect the fluid in your brain. But beyond these physical effects, gravity connects us to something deeper and more mysterious. It links us to the fundamental nature of time itself. Einstein showed us that gravity and time are intimately connected. The stronger the gravitational field, the slower time passes. This means that time literally runs slightly faster for your head than for your feet because your head is a tiny bit farther from Earth's center. This connection between gravity and time opens up some of the most mind bending possibilities in physics. Near a black hole, time would slow to a crawl relative to distant observers, and in the most extreme gravitational fields, time might behave in ways we can barely imagine. It's as if gravity doesn't just shape space, but also sculpts the very flow of temporal experience as we prepare to explore even deeper mysteries in our continuing journey. Remember that every moment you spend contemplating these wonders, you're participating in gravity's grandest achievement, the creation of conscious beings capable of understanding their place in the cosmic dance. You are literally made of star stuff, forged in gravitational furnaces and organized by gravitational forces into the remarkable complexity of a thinking, feeling human being. Gravity surrounds you, embraces you, and connects you to every corner of the universe in ways both profound and intimate. It's the force that brought you into existence, shapes your daily experience, and will ultimately guide the future evolution of everything you hold dear and perhaps most beautifully. It does all of this with such gentle persistence that you can contemplate its mysteries while feeling perfectly safe and grounded in its eternal embrace. And as we drift deeper into gravity's embrace, we find ourselves face to face with one of the most elegant paradoxes in all of science. The very force that seems to pull everything together is also responsible for tearing the universe apart in ways that challenge our deepest intuitions about reality itself. You see, gravity operates on a principle that seems almost too simple to be true. Every piece of matter in the universe attracts every other piece of matter with a force that depends on their masses and the distance between them. It's a relationship so fundamental that we can write it down in a single elegant equation. Yet from this simple rule emerges complexity that spans from quantum fluctuations to cosmic structures larger than we can easily comprehend. Imagine, if you will, standing at the edge of a great cosmic web stretching across billions of light years. This isn't a metaphor, but a literal description of how matter organizes itself on the largest scales. Galaxies aren't scattered randomly through space. Instead, they form delicate filaments and sheets separated by vast empty regions called voids. It's as if the universe has a skeleton made of dark matter and ordinary matter with galaxies strung along the bones like glowing pearls. This cosmic architecture tells the story of gravity's patient work over nearly 14 billion years. In the earliest moments after the Big Bang, the universe was remarkably smooth, with only tiny density fluctuations rippling through the primordial plasma. But gravity seized upon these minute variations. amplifying them over cosmic time. The slightly denser regions attracted more matter, which made them denser still, creating a runaway process that eventually carved out the cosmic web we observe today. But here's where our story takes an unexpected turn. While gravity was busy organizing matter into increasingly complex structures, something else was happening to space itself. The universe wasn't just expanding, it was accelerating its expansion, driven by a mysterious influence we call dark energy. This cosmic antagonist to gravity's clustering tendencies makes up roughly 70% of everything that exists. Yet we understand it about as well as medieval scholars understood electricity. Dark energy presents us with one of the most humbling mysteries in modern physics. It appears to be a property of space itself, growing stronger as the universe expands and space stretches. This means that while gravity works to pull things together, dark energy works to push them apart. And on the largest scales, dark energy is winning the battle. Galaxies that aren't gravitationally bound to each other are moving away from us at ever increasing speeds, eventually disappearing beyond the horizon of what we can ever observe. This cosmic tug of war between gravity and dark energy will ultimately determine the fate of everything we know. If dark energy continues to dominate the universe, will expand forever, cooling and diluting until even the most tightly bound structures succumb to the stretching of space stars, will burn out, black holes will evaporate through Hawking radiation, and the universe will end not in a fiery collapse, but in a cold, dark whimper. Yet, even as we contemplate this distant cosmic future, gravity continues to surprise us with new revelations. One of the most remarkable discoveries of recent decades is that gravity itself creates ripples in spacetime when massive objects accelerate. They send out waves that travel at the speed of light, carrying information about the violent events that created them. These gravitational waves were predicted by Einstein over a century ago, but remained beyond our ability to detect until very recently, when extraordinarily sensitive instruments finally caught the faint whispers of space-time itself stretching and compressing as these waves pass through Earth. The first detection came from two black holes spiraling into each other over 1 billion years ago, their final dance of mutual destruction creating ripples that traveled across the cosmos to shake our detectors by less than the width of a proton. Listening to gravitational waves is like developing an entirely new sense for exploring the universe, just as your eyes detect electromagnetic radiation. We can now feel the vibrations of space-time itself. This opens up possibilities for studying cosmic events that remain invisible to traditional telescopes. Black holes merging neutron stars, colliding perhaps even echoes from the universe's first moments when quantum fluctuations might have created gravitational waves that still reverberate through space. But gravity's mysteries extend far beyond these cosmic scales. Down in the quantum realm, where particles pop in and out of existence and uncertainty reigns supreme, gravity behaves in ways that challenge our current understanding. We know that the other fundamental forces, electromagnetism, and the strong and weak nuclear forces, can be described using quantum mechanics. But gravity stubbornly resists our attempts to fit it into the same framework. This resistance isn't just a technical problem, it points to something deeper about the nature of reality itself. Quantum mechanics tells us that at the smallest scales, everything is probabilistic and uncertain, but general relativity describes gravity as the smooth curvature of spacetime. These two descriptions seem fundamentally incompatible, like trying to describe the same landscape using both a detailed street map and an abstract impressionist painting. Some physicists believe the solution lies in recognizing that space and time themselves might not be fundamental ingredients of reality, but rather emergent properties that arise from something deeper and more mysterious, just as temperature emerges from the motion of countless molecules. Perhaps space time emerges from the interactions of more basic quantum components. Others propose that gravity might be fundamentally different from the other forces, not truly a force at all, but rather an illusion created by our limited perspective from within the curved spacetime we inhabit. It's a bit like fish trying to understand water. They're so immersed in their medium that they might never realize it exists or affects their motion. These questions touch on some of the deepest puzzles in physics. Why does gravity seem to care only about energy and mass, while the other forces distinguish between different types of particles? Why is gravity so much weaker than the other forces? And perhaps most mysteriously, why does the universe seem to be fine tuned for the existence of complex structures like stars, planets, and ultimately life itself? The strength of gravity appears to be precisely calibrated. If it were slightly stronger, the universe would have collapsed back on itself before stars could form. If it were slightly weaker, matter would never have clumped together enough to create the cosmic structures. We see this cosmic coincidence, along with many others, has led some scientists to speculate that we might live in one of countless universes each with different physical laws, and that we find ourselves in this particular universe simply because it's one of the rare ones where conscious observers like us can exist. But perhaps we're getting ahead of ourselves in our quest to understand gravity's deepest mysteries. Sometimes the most profound truths are found not in exotic theoretical speculation, but in quiet contemplation of the everyday miracles that surround us. The next time you pour water from a pitcher, watch how gravity guides each drop in its graceful arc. The liquid doesn't simply fall straight down, but traces elegant parabolas through the air, each droplet following the path that space time geometry dictates. Or consider the remarkable fact that you can predict exactly where a thrown ball will land by understanding just a few simple principles about gravity's influence. This predictability in the midst of cosmic mystery suggests something beautiful about the universe's design, that even the most complex phenomena often follow surprisingly simple rules waiting to be discovered by curious minds willing to look closely enough. Gravity also reveals itself in the rhythm of your daily life, the way your body naturally adjusts to the pull of the earth, the comfortable weight of blankets that helps signal to your nervous system that it's time to rest, the satisfying feeling of sinking into a soft chair after a long day of negotiating with gravity's constant presence. These aren't merely physical sensations, but connections to the fundamental architecture of reality. As we prepare to explore even more of gravity's secrets in our continuing journey, remember that you're not just learning about some distant abstract force. You're discovering the invisible threads that connect you to every star in the sky, to every grain of sand on every beach, to every breath of air you've ever taken. Gravity doesn't just shape the universe, it shapes the very possibility of your existence and your capacity to wonder about these beautiful mysteries. The gentle tug you feel right now, pulling you toward rest, is the same force that ignites stars' births, planets, and guides galaxies in their ancient dance across the cosmic dark. And in that connection between the most intimate and the most universal, between the personal and the cosmic, lies perhaps gravity's greatest gift. The reminder that you belong here in this vast, strange, wonderful universe, held safely in its eternal embrace. Now, as we settle deeper into our exploration of gravity's tender mysteries, we encounter perhaps its most enchanting quality, the way it transforms the ordinary into the extraordinary, right here in the quiet space where you're listening tonight. Think about the glass of water sitting nearby, if there is one, or perhaps imagine one resting peacefully on a table. That water isn't simply sitting there doing nothing. It's engaged in a constant conversation with gravity, every molecule pulled downward, creating the flat surface we take for granted. But here's what makes this beautiful: the water doesn't know it's obeying any laws of physics. It simply follows the path that feels most natural through the curved landscape of spacetime. This is gravity's gentlest whisper that the most profound forces in the universe operate not through violence or drama, but through patient, inevitable guidance, like a loving parent's hand on a child's shoulder, steering without forcing, directing without controlling. And in this tender persistence, we find one of the most remarkable aspects of our cosmic home. You see, Earth itself is constantly falling, just like that glass of water or the autumn leaves drifting past your window. Our entire planet is in perpetual free fall around the sun, following the curved path through space time that our star's mass has carved for us. And yet, this cosmic tumbling feels perfectly still to us because we're all falling together in the same gravitational embrace. It's rather like being in an elevator that's moving so smoothly, you forget you're moving at all, except our elevator is a blue marble spinning through the void, and our journey has been continuing for over 4.5 billion years with such reliability that seasons change tides, ebb and flow, and life itself has learned to dance to gravity's rhythm. But gravity doesn't just guide our planet through space, it reaches into the most intimate details of how life unfolds on Earth's surface. Consider how a tree grows, reaching upward against gravity's pull, its cells somehow knowing which way is up and which way is down the roots. Dig deep, following gravity's guidance toward the center of the earth, while the branches stretch toward the sky, creating the familiar silhouette that has comforted humans for millennia. This biological response to gravity, called gravitropism, reveals something profound about how life and physics intertwine. The tree doesn't think about gravity, doesn't calculate angles or forces, yet every cell responds to this invisible influence, shaping itself in relation to the cosmic architecture that surrounds us. It's as if life itself is a kind of slow motion sculpture carved by gravitational forces over countless generations. And what about the birds that soar past your window? Their flight isn't a victory over gravity, but rather an elegant negotiation with it. Every wing beat, every subtle shift in feather position represents millions of years of evolutionary fine tuning to work within gravity's constraints. Not against them, the bird doesn't conquer gravity. It partners with it, finding lift in the very air that gravity holds close to Earth's surface. Even more intimate is gravity's role in the blood flowing through your veins. Right now, your heart has evolved as a pump precisely calibrated to overcome gravity's pull to send oxygen rich blood upward to your brain against the constant downward tug that would otherwise pool all your blood in your feet. This is why astronauts in zero gravity experience such dramatic changes in their cardiovascular systems. Their hearts suddenly find themselves overpowered for an environment without gravity's familiar resistance. Gravity also whispers through the architecture of your bones, which grow denser in response to gravitational stress and weaker. When that stress is removed, astronauts returning from long missions in space often face challenges with bone density because their skeletons have adapted to an environment where gravity's structural demands have been lifted. It's a reminder that we are literally shaped by the gravitational environment we call home. But perhaps most mysteriously, gravity seems to play a role in consciousness itself. The delicate balance of fluids in your inner ear that gives you spatial orientation, the way your brain processes up and down, even the circadian rhythms that help regulate your sleep cycles. All of these appear to be influenced by our planet's gravitational field in ways we're only beginning to understand. Some researchers suggest that the very structure of neural networks in the brain may have evolved in response to gravitational influences, that the way thoughts flow through consciousness might be subtly shaped by the same force that guides rivers to the sea and planets around stars. It's a speculation that borders on poetry, but one that reflects how deeply gravity penetrates every aspect of our existence. And then there are the moments when gravity reveals itself most dramatically, not in its everyday constancy, but in its temporary absence. Have you ever experienced that sensation in an elevator when it begins to descend quickly, and for just an instant, your stomach seems to float? That brief taste of weightlessness offers a glimpse into how profoundly gravity shapes our normal experience by showing us what life feels like when it's temporarily lifted. Or consider the simple joy of jumping into a swimming pool, that moment of free fall before hitting the water when gravity accelerates you downward at precisely 9.8 meters per second squared, regardless of your size or weight. In that instant, you're experiencing the same acceleration that Galileo discovered applies to all falling objects, the same force that guides planets in their orbits concentrated into a moment of pure physical joy. These experiences remind us that we don't just live with gravity, we live within it, like fish swimming in water. We're so immersed in its influence that we rarely notice its presence, except in those moments when it asserts itself more dramatically, or when we briefly escape its grasp. But gravity's most poetic expression might be found in the simple act of settling down for the night, as you feel your body relaxing into rest. Gravity draws you gently toward the earth, helping to slow your movements, calm your thoughts, and ease you into the restorative embrace of sleep. It's as if the same force that holds galaxies together also knows exactly how to hold you. This isn't mere metaphor. There's growing evidence that gravity plays a subtle role in sleep cycles and circadian rhythms. The gentle pressure of your body against your bed, the way fluids settle in your tissues as you lie horizontal, even the slight tidal effects of the moon's gravity all contribute to the complex symphony of signals that guide your journey into dreams. And speaking of the moon, that silver companion that has watched over Earth for billions of years, offers us one of gravity's most visible performances every night. The moon's gravitational dance with Earth creates the tides, those great slow breaths of the ocean that have pulsed along our shores since water first covered our planet. But the moon does more than move oceans. Its gravitational influence has been steadily slowing Earth's rotation, making our days gradually longer over geological time, billions of years ago when the moon was younger and closer. Our days lasted only about 6 hours. The gradual stretching of our days due to tidal friction is gravity writing the history of time itself into the rhythm of our planet. This same tidal force is gradually pulling the moon away from Earth at about the same rate your fingernails grow so slowly that human civilization has barely noticed, but steadily enough that billions of years from now, assuming anyone is still here to observe it, the moon will appear much smaller in the sky, and total solar eclipses will become impossible. These vast, slow changes remind us that gravity operates on timescales that dwarf human experience, yet its effects ripple through every moment of our lives, from the splitting of seconds to the aging of worlds. Gravity connects us to temporal scales we can barely comprehend while remaining intimately present in each heartbeat. Perhaps this is why gravity feels both mysterious and familiar, both cosmic and personal. It's the force that brought the materials of your body together in the hearts of ancient stars, that guided those stellar remnants into the swirling disk that became our solar system, that held our planet in the perfect orbital distance for liquid water to exist for billions of years, long enough for evolution to craft creatures capable of contemplating these very mysteries. Every atom in your body, every breath you take, every thought you think exists because gravity created and maintains the delicate conditions necessary for complexity to emerge from simplicity, for consciousness to arise from matter, for wonder to bloom in minds capable of grasping, however dimly, the elegant mathematics that govern their own existence. And yet, for all our scientific understanding, gravity retains an almost magical quality. In our direct experience, there's something deeply satisfying about the weight of a well made tool in your hand, the solid feeling of good earth beneath your feet, the way a stone skips across water, following arcs that seem both inevitable and surprising. These everyday encounters with gravity connect us to something larger than ourselves, to the fundamental forces that shape reality, while remaining utterly accessible to direct sensory experience. You don't need telescopes or equations to feel gravity's presence, just the simple awareness of your own embodied existence in this gravitational field we call home as our journey continues. We'll explore how gravity becomes even more mysterious and wonderful when we consider its role in the birth and death of stars, the formation of the elements that make life possible, and the ultimate fate of everything we know. But for now, let yourself sink a little deeper into gravity's gentle embrace. Feel how it holds you safely while your mind wanders through these cosmic mysteries. There's something profoundly comforting about gravity's reliability in a universe full of uncertainty and change. This one force remains constant, faithful, always there, to catch you when you fall, always working to bring things together rather than tear them apart, always whispering through every moment that you belong here, held secure in the vast, loving arms of the cosmos itself. And perhaps that's gravity's greatest gift, Not just the physical processes it enables, but the sense of belonging it provides, the reminder that you're not floating lost in empty space, but anchored firmly to a world that is itself anchored in the grand architecture of reality, connected through invisible threads to every star that shines in the darkness above. Tonight, as we venture deeper into gravity's cosmic cathedral, we find ourselves standing at the threshold of one of the most beautiful and terrible phenomena in the universe: the birth and death of stars. Those distant suns that twinkle so peacefully in our night sky, yet harbor within their cores the most violent and creative processes known to physics. Imagine, if you will, a vast cloud of gas and dust drifting silently through the darkness of space, stretching across light years so thin that it makes the best vacuum we can create on Earth seem dense by comparison. This is a stellar nursery where gravity begins its most patient and spectacular work, not with drama or fanfare, but with the gentlest of touches over millions of years. Gravity draws these scattered atoms together so slowly that if you could somehow watch the process, it would seem like watching paint dry on a cosmic scale. Yet within this apparent stillness, something profound is happening. Each particle of dust, each molecule of gas, feels the gravitational pull of every other particle and responds by drifting imperceptibly closer. As this cosmic dance continues, the cloud begins to contract ever so slightly, and as it does, something wonderful occurs. The gravitational potential energy of all that scattered matter begins converting into heat, the same principle that warms your hands when you rub them together, but played out on a scale that defies comprehension. At first, this warming is barely noticeable, a few degrees above the absolute zero of space, but gravity is relentless. Patient as erosion carving canyons, grain by grain of sand, the cloud continues to collapse, and as it does, the temperature at its center begins to rise 10 degrees, 100, 1,000, and still gravity pulls inward, compressing the growing protostar like an invisible hand, slowly squeezing a cosmic snowball. When the temperature at the core reaches about 10 million degrees, something miraculous happens. The hydrogen nuclei, moving so fast they can overcome their natural electrical repulsion and fuse together, releasing energy in the process. This is the moment a star is born, not with a bang, but with the quiet ignition of nuclear fire deep in its heart. But here's what makes this process so remarkable: it's entirely self regulating as the nuclear reactions release energy. They create an outward pressure that balances gravity's inward pull, like two dancers perfectly matched, each responding to the other's movements. The star finds its equilibrium, a delicate balance between the force that wants to crush it and the fire that wants to tear it apart. This balance can last for billions of years. Our own sun has been maintaining this cosmic dance for about 4.5 billion years, and will continue for roughly another 5 billion more. During all this time, gravity holds the star together, while nuclear fusion pushes outward, creating the steady energy output that makes life possible on planets like ours. Yet gravity's role in stellar evolution extends far beyond simply holding stars together. It determines how long they live, how bright they shine, and ultimately how they die. A star's mass, its total gravitational pull, sets the tempo for its entire existence, like a cosmic metronome, marking time on scales that dwarf human history. Massive stars, those with many times our sun's mass, live fast and die young, Their stronger gravity compresses their cores to higher temperatures and pressures, causing them to burn through their nuclear fuel at a ferocious rate. They may shine with the brilliance of millions of suns, but their lives are measured in mere millions of years, not billions. Smaller stars like red dwarfs have weaker gravity and thus burn their fuel much more slowly. They glow with a gentle orange light that can persist for trillions of years, far longer than the universe has existed so far. Thus, stellar tortoises will still be shining long after massive blue giants have burned out and faded to cosmic ash. But it's in stellar death that gravity reveals perhaps its most dramatic artistry when a massive star exhausts its nuclear fuel. The delicate balance that has sustained it for millions of years suddenly tips gravity no longer held in check. By fusion pressure begins to win the cosmic tug of war. And what happens next occurs faster than the blink of an eye. The star's core collapses in less than a second, compressing matter to densities that beggar imagination. A teaspoon of this collapsed material would weigh as much as a mountain on Earth. The collapse happens so violently that it creates a shock wave that tears through the star's outer layers, blasting them into space in what we call a supernova explosion. For a brief moment, this dying star outshines an entire galaxy of hundreds of billions of stars. Its final scream of light, visible across cosmic distances. Yet this apparent destruction is actually one of the universe's most creative acts. The tremendous pressures of the collapse forge elements, heavier than iron, gold, platinum, uranium, all the complex atoms that make planets and life possible. These precious elements forged in the hearts of dying stars are scattered across space by the supernova explosion, seeding the cosmos with the raw materials for new worlds, new possibilities, new life. It's a kind of cosmic recycling program where gravity plays the role of both destroyer and creator, tearing apart old stars to build new ones. But sometimes, gravity's appetite is so strong that even a supernova cannot satisfy it. If the collapsing core is massive enough, nothing can stop its inward fall. Not nuclear forces, not the pressure of electrons crushed against their quantum limits. Not even the speed of light itself becomes fast enough to escape. This creates what we call a black hole, a region where gravity has become so intense that it warps spacetime into a kind of cosmic funnel from which nothing can return. The boundary of this region, called the event horizon, marks the point of no return, where space and time themselves become so distorted that our normal understanding of physics begins to break down. Yet black holes aren't the cosmic vacuum cleaners that science fiction often portrays. They don't reach out and devour everything in sight. Instead, they simply sit in space like any other massive object curving spacetime around themselves. If our sun were somehow replaced by a black hole of equal mass, Earth would continue orbiting exactly as before, though admittedly it would be rather chilly. What makes black holes truly extraordinary is how they challenge our understanding of information and reality itself. When matter falls past the event horizon, where does it go? What happens to the information encoded in its quantum states? These questions touch on some of the deepest puzzles in physics, connecting gravity to quantum mechanics in ways we're still struggling to comprehend. Some physicists suggest that black holes might actually be doorways to other regions of spacetime or even other universes entirely. The mathematics of general relativity allows for such possibilities. though whether they exist in reality remains one of the great mysteries awaiting future explorers of the cosmic frontier. But perhaps we shouldn't be too eager to solve all of gravity's mysteries. There's something beautiful about living in a universe that still holds secrets, still whispers truths. We haven't yet learned to hear the fact that we can contemplate black holes and stellar evolution at all is itself a kind of miracle made possible by gravity's patient work over cosmic time. Every carbon atom in your body was forged in the nuclear furnace of an ancient star. Every oxygen molecule you breathe was created when that star died in a supernova explosion, scattering its elemental gifts across the galaxy. You are quite literally made of star stuff held together by the same gravitational forces that created those distant suns. This connection between the most intimate and the most cosmic, between your personal existence and the death of stars billions of years ago, reveals something profound about the nature of reality. We're not separate from the universe. Looking in from the outside, we're part of its ongoing story, participants in the grand narrative that gravity has been writing since the first moments and after the Big Bang. Even now, as you rest comfortably in gravity's embrace, new stars are being born in distant nebulas, while others are dying in spectacular explosions that enrich the cosmos with the elements necessary for future worlds. The same force that keeps you gently anchored to your chair is simultaneously orchestrating dramas of creation and destruction on scales that span galactic distances and in the spaces between stars, in the vast dark regions that seem empty to our eyes. Gravity continues its patient work. Dark matter, that mysterious substance we cannot see, directly reveals itself through gravitational effects, creating the invisible scaffolding upon which galaxies form and evolve. This dark matter outweighs all the visible stars and planets by a factor of 5 to 1, yet it interacts with ordinary matter only through gravity, making it one of the most humbling reminders that our understanding of the universe remains beautifully incomplete. We can map its presence through gravitational lensing, watch how it guides the formation of cosmic structures, but its true nature remains hidden. Perhaps dark matter represents gravity's deepest secret, a reminder that the force we think we know best still holds mysteries that could revolutionize our understanding of reality itself. Just as Einstein's insights transformed Newton's clockwork universe into something far stranger and more wonderful, as we prepare to explore gravity's role in the ultimate fate of the cosmos, remember that you're not just learning about distant astronomical phenomena. You're discovering the forces that brought you into existence, that sustain your life moment by moment, and that connect you to every corner of the universe through invisible threads of gravitational influence. The gentle weight you feel as you settle deeper into rest is the same force that ignites stars, forges elements, and shapes the destiny of galaxies. And in that connection between the personal and the universal, between the tender and the tremendous, lies perhaps the most beautiful truth about our cosmic home. We belong here not as strangers in a hostile universe, but as natural expressions of the same creative forces that paint auroras across alien skies, birth planets around distant suns, and weave the cosmic web that connects all things in an intricate dance of matter, energy, space, and time. Tonight, as we drift toward the edge of our gravitational journey, we find ourselves contemplating perhaps the most profound question of all. What does the future hold for this cosmic force that has shaped everything we know and love? And what might that future mean for us, tiny conscious beings riding our blue marble through the vast darkness? You see, gravity operates on timescales that make human civilization seem like a brief flicker, yet its influence extends so far into the future that we can actually peer ahead and glimpse the ultimate destiny of our universe. Though what we see there is both beautiful and deeply humbling. Imagine, if you will, the universe as it exists today, filled with brilliant galaxies spinning through space, each one a cosmic city containing hundreds of billions of stars. But this is not how things will always be. Gravity and its mysterious counterpart, dark energy, are locked in an eternal struggle that will ultimately reshape reality itself in ways that challenge our deepest assumptions about permanence. Over the next few billion years, we'll witness gravity's influence on our own cosmic neighborhood in the most spectacular way imaginable. Our Milky Way galaxy is currently on a collision course with our nearest major neighbor, the Andromeda Galaxy, drawn together by their mutual gravitational attraction across the 4.5 million light years that separate them. This cosmic collision might sound catastrophic, but it will actually unfold with surprising gentleness. The vast distances between individual stars mean that most will simply find new orbits in the merged galaxy that astronomers have already nicknamed Milkomeda. It's rather like two vast swarms of fireflies interpenetrating each other, most never coming close enough to interact directly. During this galactic dance, which will take place over hundreds of millions of years, gravity will choreograph one of the most beautiful performances in cosmic history. Stars will be flung into new trajectories, some ejected into the darkness of intergalactic space, others drawn inward toward the supermassive black holes at each galaxy's heart. The night sky, as seen from any surviving worlds, will be transformed as familiar constellations dissolve and new patterns emerge. But even this grand merger is just a small note in gravity's longer symphony. As the universe continues to expand, driven by dark energy's relentless push, galaxies that aren't gravitationally bound to our local group will gradually disappear beyond the cosmic horizon, receding so fast that their light can never reach us. This cosmic expansion reveals one of gravity's most poignant limitations. While it can hold together structures like galaxies and solar systems, it cannot overcome the larger scale stretching of space itself. Gradually, the universe will become a lonelier place as distant galaxies fade from view, leaving future astronomers in islands of matter separated by ever growing oceans of empty space. Yet, even as the universe grows cold and sparse, gravity will continue its patient work over timescales that dwarf everything we've discussed so far. The stars we see today will eventually exhaust their nuclear fuel one by one, the universe entering what cosmologists call the stelliferous era's end, when star formation finally ceases and the cosmos begins its long fade into darkness. But darkness doesn't mean the end of gravity's story in the deep future, when the last red dwarf stars have flickered out, and even the longest lived stellar remnants have cooled to match the temperature of space. Gravity will still be there patiently, drawing matter together in ways that seem almost impossibly slow over periods measured not in billions, but in googles of years. Gravity will continue to organize matter, causing even the most dispersed particles to eventually find each other in this far future. Gravity becomes the universe's memory keeper, the only force still capable of creating structure in an otherwise featureless void. Some physicists speculate that gravity might even enable a kind of cosmic resurrection in the unimaginably distant future. Random quantum fluctuations could spontaneously create new configurations of matter, including perhaps exact duplicates of everything that exists today. It's a possibility so remote that the numbers involved have more zeros than there are atoms in the observable universe. Yet gravity would be the force that gives these quantum miracles their chance to unfold. But let's return from these cosmic depths to something more immediate and personal, because gravity's future isn't just about the fate of galaxies and stars. It's also about the continuing evolution of life and consciousness in a gravitational universe. Right here on Earth, gravity continues to shape biological evolution in subtle ways. Organisms are constantly adapting to gravitational stress, developing stronger bones, more efficient circulatory systems, better balanced mechanisms as life spreads beyond Earth to other worlds with different gravitational fields. We may witness evolutionary changes that would astound us. Imagine humans adapted to the low gravity of Mars, developing longer limbs, lighter bones, perhaps even the ability to leap great distances, or consider life forms that might evolve in the high gravity wells near neutron stars, where a teaspoon of matter weighs as much as a mountain creature's, so different from terrestrial life that we might barely recognize them as living at all. But perhaps gravity's most intriguing future lies in its potential role in expanding human consciousness itself. As we develop more sensitive instruments to detect gravitational waves, we're essentially developing new senses that allow us to feel the vibrations of spacetime directly. Future generations might grow up with gravitational wave detectors as common as radio telescopes, are today able to listen to the universe's gravitational symphony in real time, feeling the merger of black holes, the birth of neutron stars, perhaps even echoes from the universe's first moments when quantum fluctuations created ripples that still reverberate through the cosmic web. This gravitational astronomy could reveal phenomena we haven't even imagined yet. Cosmic strings, theoretical one dimensional defects in spacetime that would create distinctive gravitational wave signatures, or primordial black holes formed in the universe's earliest moments that might help explain the mystery of dark matter as our understanding of gravity deepens. We may also unlock technologies that seem like magic today. Perhaps we'll learn to manipulate space-time itself, creating gravitational fields on demand, or even achieving that science fiction dream of gravity control. Imagine spacecraft that generate their own gravitational fields, providing artificial gravity for long journeys between stars. Or consider the possibility of gravitational communication, sending messages by creating ripples in space-time that travel at light speed through the universe, unimpeded by matter or electromagnetic interference. It would be the ultimate long-distance communication system, allowing civilizations separated by galactic distances to stay in touch across cosmic time. But even if such technologies remain forever beyond our reach, gravity offers us something perhaps more valuable: a profound sense of connection to the deepest workings of reality. Every time you feel your weight settle into a comfortable chair, you're experiencing the same force that guides galaxies through their ancient dances. This connection between the intimate and the infinite, between your personal experience and cosmic evolution, suggests that consciousness itself might play a special role in gravity's ongoing story. We are the universe becoming aware of itself, contemplating its own gravitational architecture through minds that are themselves products of gravitational processes. In this sense, studying gravity isn't just about understanding a physical force, it's about understanding our place in the cosmic story, recognizing that we're not separate from the universe, but expressions of its deepest creativity, participants in an ongoing process of self discovery that spans from quantum scales to cosmic horizons. As you prepare to drift into sleep tonight, carried gently earthward by gravity's tender pull, remember that you're part of something magnificent and eternal, the same force that will guide the future evolution of galaxies is holding you safely right now, connecting you through invisible threads to every star in the sky tomorrow. When you wake, gravity will still be there, patient and reliable as it has been for nearly 14 billion years, ready to support your first steps into a new day and the day after that, and for countless days to come across timescales that stretch far beyond human imagination. There's something deeply comforting about gravity's permanence in a universe where so much changes and fades. This one force remains constant, a cosmic anchor that gives structure and meaning to the grand dance of existence. And perhaps that's the most beautiful truth we can carry with us as we rest in its eternal embrace. The universe is not just a collection of objects floating in empty space, but a living, breathing web of relationships held together by gravity's gentle insistence that everything belongs somewhere, that every particle of matter has a place in the grand design, and that includes you, dear listener, held safely in the gravitational field of a planet that is itself held in the gravitational embrace of a star, that moves in the gravitational dance of a galaxy, that participates in the gravitational symphony of the entire cosmos sleep, while knowing that you're part of this magnificent story, and that gravity will be there to catch you when you fall, to lift you when you rise, and to remind you always that in this vast, strange, wonderful universe, you are exactly where you belong. And as we drift toward the close of our gravitational meditation, we find ourselves returning to the most intimate truth of all, that gravity is not merely a force we study, but a companion we live with every moment of our existence, a silent partner in the dance of being alive. Consider for a moment how gravity has been with you throughout your entire life, from your very first breath when it helped draw air into your newborn lungs, to this quiet evening when it gently settles your thoughts toward rest. It was there when you took your first wobbling steps, learning to negotiate with its constant presence. There when you discovered the joy of jumping and the inevitable lesson of landing. Gravity witnessed your childhood games, the satisfaction of stacking blocks until they tumbled, the thrill of swings that carried you briefly toward the sky before drawing you safely back. It was your teacher in countless small lessons about balance, about the relationship between effort and ease, about the simple physics of existing in a world where up and down have meaning. As you grew, gravity shaped not just your body, but your understanding of the world around you. You learned that rivers flow downhill, that dropped objects fall, that rain descends from clouds. These weren't abstract concepts, but lived experiences written into your muscles and bones through millions of small interactions with the gravitational field that surrounds you. And now, as an adult, gravity continues its quiet ministry, helping you navigate three-dimensional space without conscious thought. maintaining the pressure in your circulatory system that keeps you alert and thinking, drawing you toward rest when your body needs repair. It's there in the satisfying weight of a good meal, the comfort of a warm blanket, the way your head naturally finds the perfect spot on your pillow. But gravity's companionship extends beyond the merely physical. It provides a kind of existential anchor in a universe that can sometimes feel overwhelming and chaotic. When the complexities of life threaten to scatter your thoughts in all directions, gravity reminds you that you have a place, you belong somewhere specific in space and time. This belonging isn't metaphorical, but literally true. Your body is precisely calibrated for Earth's gravitational environment. Your inner ear evolved to detect the subtle accelerations that help you maintain balance. Your cardiovascular system developed the exact strength needed to circulate blood against gravity's pull. Your bones grew to the density required to support your weight in this particular gravitational field. In a very real sense, you are a gravitational being shaped by and adapted to this cosmic force as intimately as a fish is shaped by water. You don't just live with gravity, you are an expression of it, a walking, talking manifestation of how matter organizes itself in a gravitational universe. This realization can be both humbling and deeply comforting. Humbling because it reminds us how thoroughly we're woven into the fabric of physical reality, how dependent we are on forces vastly larger than ourselves. Comforting because it assures us that we're not accidents or aliens in this universe, but natural, inevitable products of its deepest creative processes. When you feel gravity's pull tonight drawing you toward sleep, you're experiencing the same fundamental attraction that holds atoms together, that keeps planets in their orbits, that guides the formation of galaxies across cosmic time. The force that enables your rest is the same force that enables the existence of everything you've ever loved. And there's something almost magical about how gravity operates at the boundary between the conscious and unconscious mind. As you drift toward sleep, your awareness of gravity's presence fades, but gravity itself never stops working. It continues to hold you safely, to circulate the fluids in your sleeping body, to maintain the delicate pressures that keep you alive and dreaming in your dreams. Gravity may behave differently. You might find yourself flying or floating or falling in impossible ways. But even these dream experiences are shaped by your deep familiarity with gravitational reality. Your sleeping mind plays with gravity's rules precisely because those rules are so thoroughly embedded in your waking experience. When you wake tomorrow, gravity will greet you like an old friend, ready to support your first movements, to help you rise from bed, to stand and walk and move through another day of existence. In its gentle embrace, it will be there in your morning coffee, staying properly in the cup, in the way your feet find purchase on the ground, in the comfortable weight of clothes that hang naturally on your body. Throughout the coming day, gravity will continue its invisible work, helping to regulate your biological rhythms, maintaining the structural integrity of every cell in your body, enabling the countless small miracles of circulation and metabolism and neural activity that keep you thinking and feeling and wondering about the nature of existence. And as evening approaches, once again, gravity will begin its gentle invitation toward rest, helping to slow your movements, to settle your thoughts, to ease you into the restorative darkness where your body can repair itself and your mind can process the experiences of the day. It's a cycle as old as life itself, as reliable as the turning of the earth in this eternal rhythm. We find perhaps gravity's greatest gift, not just the physical processes it enables, but the sense of continuity. It provides the assurance that some things remain constant, even as everything else changes, that there are forces in the universe we can depend on completely and without reservation. Generations before, you have felt this same gravitational embrace, have been held by the same force that holds you now. And generations to come will continue to experience gravity's patient presence long after your own journey has ended. It connects you not just to the cosmos, but to the great chain of conscious beings who have wondered about their place in the gravitational universe as you settle into rest. Tonight, know that you're participating in something ancient and ongoing, a conversation between mind and matter, between consciousness and cosmos that has been continuing for as long as thinking. Beings have gazed up at the stars and wondered about the forces that move them. Gravity doesn't ask for your understanding or gratitude. It simply continues its work with the same patient dedication it has shown for billions of years, holding worlds together, enabling life, nurturing the conditions in which complexity and consciousness can emerge and flourish. And perhaps that's the deepest lesson gravity offers us about existence itself, that the most profound forces often work quietly, without fanfare or recognition. That true strength lies not in dramatic displays, but in consistent, reliable presence, that the universe's greatest achievements come through patience and persistence rather than force. As your breathing deepens and your thoughts begin to scatter, like leaves on an autumn wind, gravity remains your faithful companion, drawing you gently earthward toward the rest your body needs toward the dreams. Your mind craves toward the restoration that will prepare you for another day of conscious participation in the gravitational dance sleep. Well, dear listener, held safely in the arms of a force that has cradled conscious beings since the first minds opened to wonder at the stars. You are exactly where you belong in this gravitational universe, and gravity will be there to catch you when you fall, to lift you when you rise, and to remind you, always through its constant, gentle presence, that in this vast, magnificent cosmos, you are perfectly and eternally at home. Tomorrow morning, when sunlight first touches your window and you begin to stir from sleep, gravity will be there waiting patiently, as it has every morning of your life, ready to help you transition from the horizontal world of dreams to the vertical world of waking consciousness. It's a transition so smooth, so practiced, that you barely notice the complex choreography involved. As you roll over in bed, gravity guides the movement, helping your body find its new position without conscious effort. When you finally swing your legs over the edge and sit up, gravity assists in the redistribution of fluids throughout your system, preparing your circularity for the demands of upright existence. Your inner ear recalibrates, your blood pressure adjusts, your muscles engage in their familiar dance with gravitational resistance. Standing up is perhaps one of the most remarkable negotiations with gravity that you perform dozens of times each day. In that moment, when you rise from sitting, your body automatically calculates the precise amount of muscular force needed to overcome gravity's downward pull, factoring in your weight, your posture, the softness of your chair, even your emotional state. It's a computation so complex it would challenge the most sophisticated computers, yet your nervous system performs it effortlessly without a single conscious thought, and then comes walking, that miracle of controlled falling that we take so completely for granted. Each step is actually a brief surrender to gravity's pull, followed by a perfectly timed recovery. You lean forward slightly, allowing gravity to begin drawing you earthward, then catch yourself with the opposite foot, converting downward momentum into forward motion. It's a dance you learned as a toddler and have been perfecting ever since, a constant conversation between your intentions and gravity's influence. But gravity's morning ministry extends far beyond these obvious physical interactions. As you prepare your first cup of tea or coffee, gravity ensures that the liquid flows smoothly from container to cup, that it settles with a flat surface perfectly parallel to the earth below. When you add milk or cream, gravity orchestrates the gentle mixing, creating those beautiful swirls and patterns that transform simple beverages into small works of fluid art. Even the steam rising from your warm drink tells a story of gravity's influence. The heated water molecules, made lighter by their increased energy, rise upward against gravity's pull, creating those ephemeral wisps that curl and dissipate in the cooler air above. It's a miniature weather system playing out in your kitchen, driven by the same gravitational principles that guide atmospheric circulation across entire continents. As you move through your morning routine, gravity continues its quiet work in ways both subtle and profound. It helps maintain the proper distribution of cerebrospinal fluid around your brain, keeping your thoughts clear and your consciousness sharp. It assists in the lymphatic drainage that clears metabolic waste from your tissues while you slept. It even influences the way your hair falls, the way your clothes hang, the way shadows form and shift as you move through spaces filled with light. But perhaps most remarkably, gravity plays a role in how you perceive and interact with the world around you. Your sense of spatial orientation, your ability to judge distances and navigate three-dimensional environments, your instinctive understanding of balance and proportion, all of these are calibrated to the specific gravitational environment of Earth. You are, quite literally, a creature of this particular gravitational field, as adapted to its influence as a bird is to the air or a fish to the water. This adaptation runs so deep that it affects not just your physical capabilities, but your aesthetic sensibilities as well. The proportions that seem pleasing to human eyes, the architectural forms that feel stable and harmonious, even the rhythms in music and poetry that resonate most deeply with human consciousness. All of these bear the subtle influence of our gravitational heritage. We find beauty in forms that respect gravity's influence, in structures that seem to grow naturally from the earth, in movements that flow with rather than against the cosmic forces that shaped us. And yet, for all its constancy, gravity retains an element of mystery that continues to surprise and delight. Have you ever noticed how a soap bubble seems to defy gravity as it floats upward, its iridescent surface catching light in impossible ways? The bubble isn't actually escaping gravity's influence. It's simply riding on air currents that are themselves shaped by gravitational convection, creating the illusion of weightless magic in your very own home. Or consider the way a spider's web trembles in the morning breeze. each strand perfectly tensioned to support the spider's weight while remaining sensitive enough to detect the vibrations of a trapped fly. The spider doesn't consciously calculate gravitational forces, yet its web represents millions of years of evolutionary fine tuning to work within Earth's gravitational environment, creating structures of breathtaking engineering elegance. These everyday encounters with gravity's artistry remind us that we live in a universe where the most fundamental forces express themselves through beauty as much as utility. Gravity doesn't just hold things together, it creates opportunities for grace, for elegance, for the kind of natural poetry that emerges when form follows function in perfect harmony. As morning transitions into day, gravity continues to shape your experience in countless ways. The way your coffee settles in your cup during a car ride, adjusting to every turn and acceleration. The satisfying weight of a good book in your hands, the way its pages fall naturally as you turn them. The comfortable pressure of a pet curled up in your lap, sharing their warmth while adding their small gravitational influence to your own. Even your breathing is a gravitational phenomenon. Each inhalation requires your diaphragm to work against gravity's pull on your lungs and rib cage, while each exhalation receives gravity's assistance as your chest settles back to its resting position. This partnership between your respiratory system and gravitational force has been refined over millions of years of evolution, creating the effortless rhythm that sustains your life without conscious thought. But gravity's influence extends beyond the merely biological into the realm of human creativity and expression. The way a painter's brush responds to gravitational pull as it moves across canvas, creating thick impastos or delicate washes depending on how the artist works with or against gravity's influence. The way a musician's hands find their natural weight on piano keys or guitar strings, using gravity's assistance to create dynamics and phrasing that would be impossible through muscular effort alone. Architecture, too, is fundamentally a dialogue with gravity. Every building, from the humblest cottage to the grandest cathedral, represents humanity's attempt to create spaces that honor gravitational reality while transcending its limitations. The soaring arches of Gothic cathedrals, for instance, don't fight against gravity, but rather channel its forces in ways that seem to lift stone and mortar toward the heavens. In the garden, gravity reveals itself as both sculptor and gardener. Water finds its way downhill through carefully planned channels and terraces, creating the gentle music of fountains and streams. Plants reach upward toward the light, while their roots thus delve deep into the earth, each specimen finding its own unique way to thrive within gravity's constraints. Even the way leaves fall in autumn represents a kind of gravitational choreography, each leaf following its own spiraling path to Earth as it surrenders to forces larger than itself. And what about laughter? That most human of expressions carries its own gravitational signature. When laughter truly takes hold, we speak of falling into it, of being overcome by it, as if joy itself were a gravitational force that pulls us away from our usual composure. The physical act of laughing involves a complex interplay between our respiratory system and gravity, creating those characteristic rhythmic contractions that seem to shake us from the inside out. Even sadness has its gravitational metaphors. We speak of feeling heavy hearted, of spirits that are low, of depression as a weight that pulls us down. These aren't merely poetic expressions, but reflect a deep understanding of how emotional states can literally affect our relationship with gravity, changing our posture, our movement patterns, our sense of lightness or burden as we move through the world. Perhaps this is why activities that temporarily alter our relationship with gravity, swinging, diving, dancing, even something as simple as lying down after a long day standing, can be so emotionally powerful. They offer brief respites from our usual gravitational routine, moments of altered perspective that can shift our entire sense of being in the world. As afternoon light begins to slant through windows, casting longer shadows and painting familiar spaces with golden hues, gravity continues its patient work. Dust motes dance in the light beams, their movements a delicate balance between gravitational pull and the random motions of air molecules. It's a microscopic ballet performed in the space between your eyes and the window, visible only when conditions are just right, reminding you that even the smallest particles participate in gravity's grand choreography. The way light itself bends around massive objects, including our own planet, means that the very illumination by which you see the world carries information about gravitational fields across cosmic distances. The sunset you watch this evening will arrive at your eyes having traveled through gravitational influences that have subtly altered its path, carrying within its photons the invisible signature of every massive object it has encountered on its journey from the sun to your retina. And as evening approaches, gravity begins its gentle invitation toward rest once again. Your circadian rhythms, those internal clocks that regulate everything from hormone production to body temperature, are themselves influenced by gravitational tides, so subtle that we're only beginning to understand their effects. The moon's gravitational pull that moves entire oceans also moves the water in your body, creating tiny but measurable variations in the fluid pressures that help regulate your biological processes. This is perhaps the most beautiful aspect of our gravitational existence, the way it connects the most intimate processes of your body to the grandest cycles of the cosmos. Your heartbeat, your breathing, your sleep cycles, even the electrical activity in your brain, all pulse in rhythm with gravitational influences that link you to the moon, the sun, and the turning of the earth itself. Tonight, as you prepare once again for sleep, remember that you're not just resting, but participating in a cosmic rhythm that has been ongoing for billions of years. The same gravitational forces that guide your body toward rest also guide the slow evolution of galaxies, the birth and death of stars, and the patient dance of planets around distant suns. In settling into sleep, you're trusting yourself to forces vastly larger and older than human consciousness, yet forces so perfectly calibrated to support life that they've enabled the emergence of beings capable of contemplating their own existence. It's a trust so fundamental that we rarely think about it, yet it represents one of the most profound acts of faith we perform every day. The faith that the universe will continue to hold us safely while we surrender to unconsciousness. And tomorrow, when consciousness returns and a new day begins, gravity will be there again, faithful as sunrise, ready to support another day of existence in this gravitational universe we call home, ready to catch you when you fall, to lift you when you rise, and to remind you through its constant gentle presence that you belong here, held safely in the invisible embrace of forces that connect you to everything that was, everything that is, and everything that ever will be. Sleep well, dear listener, knowing that you rest in the arms of the cosmos itself, cradled by the same forces that cradle galaxies, and that in the morning, gravity will greet you like an old friend, ready to dance with you through another day of this beautiful, mysterious, gravitationally bound existence we share. And as we reach the gentle conclusion of our gravitational journey together, perhaps the most wonderful truth of all is simply this: you have spent these quiet moments contemplating forces that shaped the very atoms of your being, and in doing so, you've participated in one of the universe's most remarkable achievements, matter becoming conscious of itself. Every thought you've had while listening, every moment of wonder or curiosity or peaceful reflection represents billions of years of gravitational work culminating in the emergence of minds capable of grasping their own cosmic context. You are not separate from the gravitational phenomena we've explored tonight. You are one of them, a walking, talking expression of how gravity sculpts reality into ever more complex and beautiful forms. The sleepiness you might be feeling now, that gentle tug toward rest and dreams, is itself a gravitational phenomenon. Your body responding to Earth's pull, your circadian rhythms synchronized with the great celestial dance, your consciousness preparing to surrender once again to the same forces that govern the motion of stars and the formation of galaxies across the cosmic deep. In a universe where so much seems uncertain and chaotic, gravity offers us something precious: the assurance that some things remain constant, that there are forces we can depend upon completely. Whether you wake tomorrow or in 100 years, gravity will still be there, patient and reliable, ready to catch falling leaves and guide planets in their orbits with the same gentle persistence it has shown since the first moments after creation. This constancy isn't just physical, but deeply spiritual in its implications. It suggests that the universe operates according to principles of care and connection, that everything is held together not by violence or coercion, but by an attraction so fundamental it predates the existence of consciousness itself. Gravity whispers to us that belonging isn't something we must earn or achieve. It's built into the very architecture of reality. So as you drift toward sleep tonight, carried earthward by gravity's tender insistence, remember that you're not just ending another day, but participating in a cosmic rhythm that connects you to every conscious being who has ever wondered at the stars. The same forces that guide your breathing and settle your thoughts also guide the great spiral arms of galaxies as they turn through space like vast cosmic pinwheels, seated with billions of worlds where other minds might be contemplating these very mysteries. Your dreams tonight will unfold in a brain held stable by gravitational forces, nourished by blood that flows according to gravitational principles, protected by an atmosphere that gravity keeps wrapped around our spinning world like a soft blanket. Even in sleep, you remain embraced by the cosmic architecture that made your existence possible. And when morning comes, as it always has and always will, you'll open your eyes to a world where gravity continues its quiet artistry in ways both grand and intimate. The first light streaming through your window has traveled 93 million miles, its path subtly curved by the gravitational influence of every massive object it encountered along the way, arriving at your retina carrying the invisible signature of our sun's gentle warping of spacetime. As you stretch and yawn, feeling that familiar heaviness in your limbs that signals the transition from sleep to wakefulness, you're experiencing one of gravity's most personal gifts, the way it helps anchor consciousness back into the physical world. Your inner ear recalibrates to the planet's pull, your blood pressure adjusts to vertical orientation, and somewhere in the background of awareness, your body performs thousands of tiny calculations to maintain balance in Earth's gravitational embrace. But perhaps the most remarkable thing about gravity isn't its cosmic grandeur or its role in stellar evolution. It's the way it makes the extraordinary feel perfectly ordinary. The fact that you can predict where a tossed ball will land, that water always flows downhill, that dropped objects fall rather than float away. These aren't miraculous exceptions to natural law, but rather the most fundamental expressions of how reality organizes itself. This predictability in the midst of cosmic mystery suggests something profound about the universe we inhabit. Despite its vast scales and incomprehensible energies, despite dark matter and black holes and the accelerating expansion of space itself, the cosmos operates according to principles we can understand, at least partially. A child learning to walk is conducting experiments in gravitational physics, discovering through trial and gentle error the same principles that govern the motion of planets and the formation of galaxies. In this sense, gravity serves as a bridge between the known and unknown, the familiar and mysterious. It's simultaneously the force that keeps your coffee in its cup and the invisible architect of cosmic structure spanning billions of light years. It's both utterly reliable. You've never worried that gravity might take a day off, and deeply enigmatic, operating through mechanisms we're still struggling to comprehend at the deepest levels. As our quiet exploration draws to its close, consider carrying with you this gentle paradox that the most fundamental force in your daily experience remains one of physics' greatest mysteries. Every step you take is a negotiation with curved spacetime. Every breath you draw is enabled by gravitational processes. Every heartbeat pulses in rhythm with tidal forces that connect you to the moon and stars. This connection isn't metaphorical, but literal, measurable, real. The water in your body responds to the same lunar pull that moves entire oceans. The iron in your blood was forged in stellar cores, held together by gravitational compression. The very ground beneath your feet exists because gravity gathered cosmic dust into our planet over billions of years of patient accumulation. So tonight, as you settle once more into gravity's embrace, remember that you're not simply going to sleep, but participating in one of the universe's most ancient and ongoing conversations, the dialogue between matter and space-time, between individual consciousness and cosmic structure, between the intimate scale of human experience and the vast scales on which reality unfolds. Sleep well, dear listener, knowing that the same gentle force that draws you down into rest also holds together everything you've ever loved, every person, every place, every moment of beauty you've witnessed. Gravity doesn't just govern the motion of celestial bodies, it enables the very possibility of stable worlds where consciousness can emerge, flourish, and contemplate its own existence. And in the morning light, when you wake refreshed and renewed, You'll find gravity waiting there as it always has, not as some distant cosmic phenomenon, but as an intimate companion in the dance of existence. The gentle weight of your blankets, the way your feet find solid purchase on the floor, the satisfying heaviness of that first cup of coffee. All of these are love letters written in the language of curved space-time, reminders that you belong here in this gravitational home we call the universe. Perhaps that's the most beautiful lesson gravity offers us in the end, that belonging isn't something we achieve, but something we simply are. From the moment matter first began to clump together in the cosmic darkness to this very instant, as you listen to these words, gravity has been weaving the story of connection, demonstrating through its patient persistence that separation is the illusion and unity is the deeper truth. Until we meet again in another gentle exploration of the cosmos, know that gravity's story is far from finished. Every breath you take between now and then is part of its continuing narrative, every heartbeat a small but essential chapter in the grand tale of how the universe holds itself together through nothing more mysterious than attraction itself. Whether you find yourself gazing up at the stars tomorrow night, or simply feeling the comfortable weight of existence as you move through your day, remember that you're never truly alone. You're accompanied always by this most faithful of cosmic companions, this gentle force that asks nothing of you but gives everything in return: stability, belonging, and the profound assurance that in a universe of unimaginable vastness, you have a place that is unshakably yours. Thank you for joining me on this quiet journey through gravity's embrace. If these whispered secrets of the universe have brought you a moment of peace, I'd be ever so grateful if you shared this little corner of calm with someone who might need it. After all, like gravity itself, knowledge becomes more beautiful when it draws us together rather than apart. Sweet dreams, dear listener, and may you rest well in the knowledge that the same force cradling you tonight has been writing the story of existence itself since time began and will continue long after our brief chapter has ended, patient and eternal as the turning of worlds, until our paths cross again in the infinite library of cosmic wonder. Sleep peacefully in gravity's gentle hold, knowing that tomorrow's sunrise will find you exactly where you belong, here, now, perfectly positioned in the grand choreography of the universe, held safe in the arms of forces so ancient and reliable that they need no introduction, ask no permission, and offer no apologies for the simple miracle of keeping everything, including you, exactly where it should be.